Okay, so first things first, regarding the validity of this question. See, the equations that we can derive out of the three cases explained here gives us a mathematical model which is which is mathematically valid, and therefore this structure is physically possible, which makes this question a valid one, and therefore its options. Okay, so yes, this question is correct, and there is nothing wrong with the options given. There is nothing wrong with the practicality of this this 3D figure here. So yes, once we understand that fact, we can now start solving the question. Now, as the case with any other question which is based on center of mass, determining the center of mass, this question also is based on selection of is based on determining the center of mass, which is primarily based on selection of origin. Or in other words, if you have to find the center of mass, you'll have to first choose a origin. And what can be the possible selection or possible cases for origin? In this question, we can choose. Well, actually, there can be any n number of origins, but to make much of mathematical sense, we can choose 3 points as to be the origin. One, the center of mass of the composite figure, which in this case is G. The center of mass of the largest sphere, which in this case is C. Center of mass of the smallest or the cutout sphere, which is O. Okay, so there are 3 possible origin selection. 1, center of mass G. 2, center of mass C. And 3, center of mass O. Okay, and when you use center of mass of the smaller sphere, which is O, as the origin, and then you find out the center of mass of the composite figure, you get the equation 2r cube minus r to the power 4 is equal to 1. If you use center of mass of the composite figure, what you get is r square minus r plus 1 is equal to r cube. But when you use the center of mass of the larger sphere, that is C, as the origin, you arrive at the equation r square minus r plus 1 into 2 minus r is equal to 1, which overlaps with the option C here, which is therefore the correct answer. Okay, so that's how we make sense of this flow written here. So these equations are consistent. 2r cube minus r to the power 4 and r square minus r plus 1 and 2 minus 1 to r is equal to 1, and r square minus r plus 1 is equal to r cube. These equations are consistent, and therefore the mathematical model is correct, which makes this case physically possible, and therefore makes the question valid in nature. Okay, now having said that, let us now jump directly into the solution. Now what we will do is, we will first solve this question using center of mass of largest sphere in a detailed way. Okay, we'll go through every possible step and then quickly glance through what happens in a center of mass of G and center of mass as O. All right. Okay, moving on to the solution. Now, how do we approach the diagram? See, to make sure that we get the markings correct, what I've done is I've taken xy axis, the coordinate axis. And okay, let me just highlight this. Mind you guys, this is not with the chosen origin. No, this is not with the chosen origin. This is just a Cartesian plane wherein this figure is drawn. Okay. Now, why am I doing this? Because we are trying to understand the practical feasibility of this diagram. This is a very small sphere. How small it is? Let us try to understand. So it is given to us that the smaller radius is 1. So if you name this, let us say this is x, right, and this is y, we can say that OC or OX is equal to 1. So it's a very small radius, right? It's a very small sphere which has been cut off. So this length here, OB, is equal to 1. Why? Because the radius is 1, right? So OB is equal to 1. So what I have done is I have assumed this scale in such that 3 divisions here represents 1 centimeter. Okay, so we've got 3 divisions here which represents 1 centimeter. So which means this sphere here is a two-dimensionally, it's a circle with radius 1. Alright, and in which case, if you see, GC here is a very small distance, right? GC, which is actually equal to 2 minus R, is a very small value. Some of I think while you go through the question the first time, the biggest concern here that arises is with the measurements. Okay, so that's why I'm taking you through the measurements in detail, and then we'll go to the solution of center of mass. Okay, right. So make sure you draw this one time along with me. If possible, take a scale, a graph paper, and then try to draw this. Make more sense to you. Okay, right. So after you draw this figure, what is the next thing that you do with respect to this question? For that matter, with respect to any such question which is based on center of mass. And what would that be? Exactly, it would be to analyze what are the bodies present. So in this case, we have 3 bodies. Sphere 1, the largest sphere, which is centered at C. The smaller sphere, which is cut off, the sphere 2, which is centered at what? Centered at O. And we have the composite figure, which is the largest sphere minus the smallest sphere, the subtractive composite figure with mass m1 minus m2, which is having a center of mass x bar comma y bar, and at which position? At position G. Alright? Okay. So sphere 1, m1, r1 is equal to capital R, center of mass coordinates x1 comma y1. Sphere 2, mass is m2, r2 is the radius, which here we'll take it as r. Okay. Center of mass coordinate is x2 comma y2. The mass of the composite figure is m1 minus m2. Why? Subtractive. The mass is removed, and the center of mass is x bar comma y bar. Okay. One more time. The largest sphere, mass m1, has a radius capital R, with the center of mass of this largest sphere as x1 comma y1. Sphere 2, the cutoff sphere, m2, radius as small r, x2 comma y2. As the center of mass of composite figure, right? Okay. Now, where will you choose the origin? You can choose the origin either to be the center of M1, the geometric center of M1, or you can choose the origin to be center of mass of mass 2. You can geometric center of mass 2, or the center of mass m1 minus m2. Okay. Now, what we will do is, we will first try to choose the origin as the geometric center of sphere 1. Geometric center of sphere 1. Now, please note the change here. What is the change? The change is that in this reference figure, I have just placed the sphere in such a fashion that the origin is not at C. The origin in this figure is, according to this figure, the origin is at O. Okay. Please make sure you understand this difference well. Now, what have I done? I have shifted this origin as the geometric center of sphere 1. So the largest sphere, the geometric center of that sphere, which is, what point is that? The point is C. The C is now at origin. So note this change. One more time. This was a reference figure. I have made a new figure. What is the change? What is the change? The reference figure had a origin of Cartesian plane at O. The new figure has the origin as the geometric center of sphere 1, which is C. So O is the origin here. C, well, to be more precise, O is placed at origin, C is placed at origin. Okay? Again, guys, please make sure that you draw this thing with me. Write down the solution one time and then try to explain it yourself. Things will become really more clear to you and more permanent in your concepts. Okay? Right. Now, if this is the case, right? If this is the case, what is radius of circle 1? It is CA. CA, right? Or can also be equal to CB. Why? Because CA and CB represent the same radius, which is equal to R. So I'm taking CA is equal to R. Okay. Now, geometrically, what is CA? It is the sum of CO and OA. So we have CO plus OA is equal to R, right? We have CO plus OA is equal to R. Now come to diameter of circle 2. You might be wondering why. Give me a minute, I'll come right to that. So what is diameter of circle 2? Circle 2 is a smaller sphere here, which is OA. I'm sorry, we're talking about diameter of circle 2. So diameter of circle 2 is GA. This complete, let me just mark this. So diameter of circle 2 is this length, which is GA, right? GA. Now, why radius and why diameter will just come in a minute, okay? So diameter is GA. How do you write GA? GA can be written as GO plus OA. GO plus OA. What is the radius? Radius is given to us as 1. Therefore, GO will be 1, OA will be 1, and therefore diameter of the circle is 2. Diameter GA is equal to 2. Okay? Now let's see, why do we have this? Let's try to understand that. So I've removed all the spheres and circles. Why? Because I need to measure JC. So to have better clarity, I've removed the circles. Okay? But we know from the previous part that radius of circle 1 is R and the diameter of circle 2 is GA is equal to 2. So we'll begin with here. Begin the derivation here. So what is GA equal to? 2. So if GA is equal to 2, can I say that GA, which is mathematically this length, GA written as GC plus CO plus OA is equal to 2? But what is CO plus OA? CO plus OA is equal to R, and therefore GC can be written as GC plus R is equal to 2, and therefore GC is equal to 2 minus R. Okay, so this is the first step that you that should become very clear to you, because the complete equation is based on 2 minus R. Now you may claim that since all the options has 2 minus R, therefore we shouldn't be spending much time on finding out whether 2 minus R is correct or not, because all of the options have it. Yes, I do understand that. Now see, we're not here to make jugad answers and then just save some time. No, what we're trying to do is we're trying to understand the concept behind every question. What is that the question trying to evaluate in you? This question is not about finding the center of mass. No, this question is primarily about evaluating whether you know to differentiate a question based on the selection of center of mass or selection of origin. All right. So to appreciate that evaluation is about learning. It's about cracking the JEE mains. Okay. Now you might also be wondering, why is this distance GC is equal to 2 minus R relevant? Because GC is the distance of center of mass of sphere 1 with respect to origin C. I'm sorry, this is not center of mass 1. Center of mass of what? Center of mass of the composite figure with respect to the origin C. Okay. Yes. Now refer to your previous diagram. Read the sentence. Write this along with me, and try to make sense by drawing by referring your diagram, and things will become really clear to you. Okay. Right. Now let's see the calculation. So what is center of mass of sphere 1? Center of mass of sphere 1, being a symmetric figure, is the geometric center, which is at C. Now, if I were to write the center of mass of sphere 1 as x1 comma y1, then I can say that the x1 comma y1 should be the geometric center, which is chosen to be C. So the geometric center is C, and since C is chosen as the origin, is equal to 0 comma 0, right? Yes, see now, now I do understand what's going through your mind. You're like spend almost 15 minutes, and now you begin with the answer. Yes. I apologies for that from the deep of my mind, from the core of my mind. I'm so sorry, but what we need to understand is it is not the solution, but how we arrive at the solution that gives you confidence in solving further questions, right? So I'm not, I'm not. Suggesting that you understand every question in this detail. No, but if you learn this question, given the trend of previous year questions, the next time a similar question comes, you will be, if you have practiced this question well enough, you will be in a state of mind to approach the question with much better confidence, which is very essential when it comes to approaching a question in an exam hall, in an exam setting where you approach where you approach one question for the first time. You are like, you might find it very difficult and challenging to solve it. That's why solving these questions in detail become important to understand the concept, right? Sorry, I took some more time again. Sorry. Okay, so now let's come to sphere 2. So sphere 2, which again is a symmetric figure, and by virtue of its symmetry, the center of mass of the sphere 2 would be the geometric center, which is at O. And if I were to say that the center of mass of sphere 2 is x2 y2 with respect to C, then I can say that x1 is equal to r minus 1 and y2 is equal to 0. Therefore, x2 comma y2 will be equal to r minus 1 comma 0. Yes, I can see that some of us may want much more clarity here. We'll go through that. So we have COA. We got COA, right? CO and A. What is C? Origin. What is O? The x coordinate of center of mass, which is x1 comma 0, right? Now what is x1? Let's see. CA is r, because CA is the radius of the largest sphere, so CA is equal to r. But what is OA? OA is 1, exactly, and therefore CO should be equal to r minus 1. Yes, please write this, please draw this one more time. Okay, now let's see the center of mass of center of mass of the third figure, which is actually the composite figure, right? So we assume that the center of mass of the remaining portion, the composite figure, is x bar comma y bar, and x bar is the x coordinate of center of mass with respect to origin C. Now what is that length? So x bar is the x coordinate of G from C, right? X coordinate of G from C, and therefore this actually should refer to the length GC. What is that? That length is 2 minus r right? And we know what would be y bar. Y bar would be equal to 0. So how do we arrive at this? Let's see. So G, C, C is the origin, chosen to be the origin, 0 comma 0. What is G? X bar comma y bar. Y bar is 0. Why? Because the line on the point on the x axis. Now what is x bar? X bar translates to GC. How did we find GC? You have it in your note, right? So GC is equal to 2 minus R. Now coming back to the discussion on the entire part of the solution. So we have larger sphere with M1, smaller sphere and composite figure with M1 minus M2. Now see, since all of these represent the same, the original structure, we can say that all three of them will have the same mass density rho. What is mass density? Rho is equal to mass by volume, M1 by V1, M2 by V2, right? So what will be M1? Rho V1, rho V1. What will be M2? Rho V2. What is V1? Being a sphere, volume of the sphere will be 4 by 3 pi r cube, 4 by 3 pi r1 cube. Since r1 is r, this would be capital R cube. The smaller sphere is of radius 1, so it will be 4 by 3 pi r cube. R being 1 is 4 by 3 pi 1 cube. And what is M1 minus M2? Would be the difference of rho V1 minus rho V2, which is equal to 4 by 3 pi into r cube minus 1 cube, r cube minus 1 cube, r cube minus 1. Yes, I want you to write this along with me. Please spend a couple of, no, not a couple of minutes. I think I would take 5 to 7 minutes to clear this. But please pause this, draw this figure, write down these values one time, just one time, and and in the future questions you don't need to do that, right? Okay. So can I now say that the larger sphere has mass 4 by 3 pi r cube rho and x1 equal to 0. Smaller sphere mass 4 by 3 pi 1 cube rho and x2 r minus 1. The composite figure m1 minus m2 being mass 4 by 3 pi into r cube minus 1 and x bar is equal to r minus 2. But why do we have minus here? I'm so sorry, my bad, I didn't explain that part. So this is wrong. Yes, I'm pretty sure some of you might have noted this, and if you have, applaud. I'm so sorry. I'm really sorry for this, and if you've done this, I really appreciate that. So this should be minus 2 minus r. Why? Because C is chosen to be the origin, and since G is to the left of this, all values coming to the left of will be taken negative, and all values that come to the right of this would be taken as positive. So O and A will be positive, whereas G would be negative, right? So therefore we have minus 2 minus r. Apologies again. So yes, so coming to this. So now basically what do we have? We have m1 x1 m2 x2, and we have m1 minus m2 and x bar. What can we derive out of this? Yes, exactly. What we have is the formula for center of mass of the composite figure, which is x bar equal to m1 x1 minus m2 x2 by m1 minus m2, right? What is x1? 0. What is x2? r minus 1. What is x bar? Minus 2 minus r. What is m1 minus m2? 4 by 3 pi into rho r cube minus 1 cube, right? Now, once we have this, if we divide this complete RHS by 4 by 3 pi rho, what happens? These terms get reduced to 1. And since this is into 0, this term vanishes. So what we have is minus r minus 1 by r cube minus 1 cube, right? Minus r minus 1. So now I can cancel off this minus and this. So this becomes 2 minus r into r minus 1 divided by r cube minus 1 cube. Now, what is a cube minus b cube? Okay, let me just write it down. So a cube minus b cube is a minus b into a square minus ab plus b square. So r cube minus 1 cube will be r minus 1 into a square, r square minus ab, r into 1 minus r plus b square plus 1 square, right? And from this two steps, r minus 1 by r minus 1 is 1. So what we have is 1 by r square minus r plus 1 is equal to 2 minus r. And if you cross multiply, what you get is 2 minus r into r square minus r plus 1 is equal to 0, which gives us the correct option as option C. Okay. Okay. Now, being at the end of the solution, I will also like to make a statement here that if you find any logical error or any mathematical error in the calculation, see, to err is human, so there may be a case that I have made some error here. Please make sure that you convey that to me, and I will go through it one more time, and we'll see how things work out. Okay. So this is the equation, this is the solution. Based on which method did we use so far? So yeah, so we were using center of mass of the largest sphere as origin, and therefore we arrive with this equation: r square minus r plus 1, 2 minus r is equal to 1. Okay. Now, before you watch the next solution, please make sure you spend some time in finding center of mass as center of mass by choosing the origin to be center of mass of the composite figure and of the smaller sphere. Things will become more clear to you. You will be more confident in approaching a similar question. Okay. Right. So I took really long to explain you this. I do understand that. Apologies for that one more time. Okay. Now let's move to the next question.